Welcome to the exciting journey of data stores and data structures. This unit marks the beginning of your advanced exploration with Make, addressing a topic frequently requested by our community. Here, you will delve into the essential elements of data handling. First, we'll unravel the concept of a data structure. Think of it as an organized framework for storing and managing data efficiently. Understanding this will lay the foundation for your future projects. Next, we guide you through creating your own data structures. This hands-on experience will empower you to tailor data management to your specific needs. We'll also emphasize the importance of data integrity and consistency. These principles ensure that your data remains accurate and reliable over time, underpinning all successful data-driven tasks. Grasping these concepts is crucial as they will significantly influence the scenarios you develop throughout this course. Let's embark on this insightful learning experience together. In this unit, we're diving into some exciting aspects of data management. First, you'll explore the fundamental concepts of data structures. These are essential blueprints that define how data is organized and accessed. Next, you'll get hands-on experience by creating your own data stores. These are repositories where you can efficiently manage and retrieve large amounts of data. You'll then learn to build scenarios that inject and utilize data within these stores, offering practical applications of the theory you've learned. We'll also cover the dynamic use of webhooks to update data stores in real time. Throughout this process, you'll encounter array aggregators which allow complex data grouping, ensuring you maintain data integrity and consistency across all operations. Get ready to enhance your data handling skills and apply them in real-world scenarios. Data structures are fundamental to managing and transferring data effectively. In this context, they act as blueprints, defining the types and organization of data within a system. For example, think of a city data structure. This structure includes collections of items like the city's name, which is a text label, its dialing code as a number, and the current time represented as a date. Each element has a specific purpose and data type, ensuring consistency in the way data is handled. Imagine a bundle as a container holding multiple collections, like a package containing similar items. This standardized approach allows you to efficiently manage complex data sets while ensuring accuracy and integrity, crucial for effective data processing and analysis. Data structures play a crucial role in how we manage and utilize information within data stores. Think of a data store as a specialized database in your Make account, designed to keep your data organized and accessible. In this system, data is stored as records, which are like individual entries in a well-organized library. Each record consists of a label, such as name, paired with its corresponding data, like Paul. These components together create a structured format. This uniformity across all records ensures consistency, making it easier to manage and retrieve information without errors. Understanding and implementing these data structures can significantly enhance the effectiveness of your scenarios. By ensuring each piece of data adheres to a predefined format, you minimize mistakes in data processing, such as mapping or validation errors. This consistency is key when developing scenarios that rely on accurate and dependable data handling. Data structures play a crucial role in managing data through webhooks. Imagine webhooks as special messengers that wait for new information and then immediately spring into action. They can trigger a specific scenario, such as an automated workflow, whenever new data arrives. When setting up a webhook, you can outline its data structure within the custom webhook module. This allows you to specify which pieces of information are essential. For instance, if a particular item is marked as required, your scenario will only proceed if this information is present. Otherwise, the data is automatically rejected and the scenario doesn't run. Consider a practical example. Paul is using a webhook to gather responses for his birthday party. He needs each response to include both the name and email of the attendee. Here, both items are part of the data structure. Name and email are necessary for the automation to proceed. If someone forgets to provide their email, the system halts, ensuring no scenario errors occur and no unnecessary operations are consumed. This strict control over data input ensures that your systems run smoothly by preventing incomplete or erroneous data from bogging down your processes. It's a great way to efficiently collect and manage the information you truly need. When working with data structures, one significant advantage is handling errors efficiently. By generating errors within Make, you have complete control and can utilize error handling directives to manage these issues effectively. This means that instead of encountering errors from an external third-party application, which might lead to additional charges, you address them directly within your scenarios. Additionally, preventing data from being sent to third-party applications avoids accidental errors on their end, thus saving you from potential fees if those apps are paid services. Moreover, by not triggering the HTTP module when not necessary, you conserve operations, which is both resourceful and cost-effective. This use case highlights the importance of defining your data structure precisely, ensuring that required fields like an email address contain the necessary information before being processed or sent out. Remember, controlling your data flow and structure not only enhances efficiency but also significantly reduces operational risks and costs. Now that you've got a grasp of what a data structure is and its importance, let's delve into the various ways you can create one. This knowledge will be essential as you start building scenarios using data stores and data structures in the upcoming units. The process of designing a data structure can be approached from different angles. Two primary methods are using data stores and modules within a scenario builder. Each method offers unique advantages and can cater to different needs, depending on your project requirements. With data stores, you can concentrate on managing and retaining structured data efficiently. On the other hand, utilizing modules in a scenario builder allows for more dynamic and interactive data structuring. In the following sections, you'll have the opportunity to explore how these methods work and apply them in practical scenarios. Don't worry about taking any action just yet. For now, focus on understanding the concepts, and soon you'll put this knowledge into practice. Creating a data structure is an essential step when setting up a data store. Here, you can give your data store a meaningful name, making it easier to identify and use later on. Next, you'll specify the data structure itself. This involves outlining the kind of data you'll be storing, which helps in organizing and accessing the data efficiently. Additionally, you can define the size of your data storage, measured in megabytes. This allows you to manage resources effectively, ensuring you have adequate space for your data. Remember, defining your data structure at this stage is crucial as it will help streamline your workflow in future projects. You'll be using this method in the upcoming steps, so it's important to understand the foundation we're building now. Now that we're exploring data structures, let's dive into how you can create them within scenarios. A data structure serves as the blueprint for how your parsed data will be organized and accessed. Think of it as creating a framework that helps your data communicate effectively within your applications. You can set up a data structure using tools like the Create Parse JSON modules. These allow you to format your data in a way that the system can easily interpret and manipulate. Additionally, the custom webhook module offers another pathway for defining data structures, ensuring compatibility with incoming data streams. In previous courses, you might recall using JSON modules to simulate various data structures. This was crucial for understanding how data could be structured and retrieved effectively. By knowing how to create these structures, you enhance your ability to manage complex data workflows, paving the way for more efficient data manipulation and storage solutions. As you continue, consider how each choice in structuring data supports the overall functionality and efficiency of your scenario. This understanding will be foundational as we move forward into practical applications and use cases. Welcome to this activity where we'll lay the foundation for your data journey by creating a new data structure. This structure will be essential as you build a use case utilizing data stores throughout the course. Think of a data structure as a blueprint or framework that organizes and holds your information, making it easier to manage and utilize later on. In this unit, our focus will be solely on creating the data structure itself. You'll have the opportunity to fill it with actual data in the upcoming units. Understanding this process is key because it sets the stage for building more complex scenarios where data stores can read and store information effectively within your projects. Data stores act like internal databases, allowing seamless data management within and across different scenarios. Today's task is simply about getting familiar with initiating a data structure, which you'll continue to work with in subsequent lessons. Remember, creating a strong foundation here will make your future data handling much smoother. Let's get started on setting up this important component. To begin creating your new data structure, you'll start by accessing the configuration settings of your data store. This is crucial for ensuring your database is set up precisely to your specifications. If you choose not to define a specific data structure, your database will contain only the primary key. This setup is particularly useful if your sole interest is in verifying whether a specific key exists in your database without the need for additional data. Additionally, remember to specify the size of your data storage in megabytes. It's important to understand the constraints here. The size must be a number between 1 and 799,989. This range allows you to tailor the storage capacity according to your project's needs. By focusing on these details, you are ensuring a streamlined data storage process, essential for efficient data management throughout your course. Now, let's get into the details of creating a new data structure. Begin by updating the name to Make Advanced C01 Data Structure. This change helps keep things organized and identifiable. Next, you'll decide on the structure's specifications. One important decision is whether to use a strict format. Selecting Yes ensures that the data structure will only accept payloads matching its exact specifications. Any additional or unspecified items in the payload will lead to rejection. This option is crucial for maintaining data integrity and preventing unexpected errors. After making these selections, your next task is to define the individual data items that will compose this structure. These data items will form the blueprint, reflecting the specific data types and parameters you plan to use. Each item can be added individually, giving you full control over the data structure as designed. Remember, choosing the right options helps ensure your data structure is both efficient and secure, setting a strong foundation for your operations. Welcome. Let's dive into specifying your data structure, a key part of organizing your data effectively. When you create a data structure, you define criteria for each item it includes. Think of each item as a package containing a label like name or address and a specific data type such as text, numbers, or more complex formats like arrays or collections. This setup allows you to clearly outline what kind of information is stored and how it's organized. You have two options to add items to your data structure. First, you can manually add them using the Add Item button. This method is great if you want full control over entering each label and its data type one at a time. Alternatively, if you already have your structure outlined in JSON, XML, form data, or a query string, you can generate these items automatically. This approach can save you time by allowing you to import existing configurations, ensuring consistency and accuracy. Don't forget the importance of strictness in your data structure. Choosing to enforce strict specifications ensures that any incoming data perfectly matches your structure, preventing errors by rejecting unexpected or extra items. These tools make building and maintaining your data structures more efficient, ensuring your data is accurate and reliable. To specify items in your data structure effectively, it's important to understand the options available to you. When you begin adding an item, you'll need to define several key attributes. First, choose a meaningful name for the item which serves as its unique identifier. Next, select the appropriate data type. This could be text, number, date, or another format, depending on the nature of your content. You can also decide on a default value, which is useful if the item needs a baseline setting. Consider whether the item is required. If it is, ensure that users must provide a value for it to proceed. There's also the option to specify if the field can be multi-line, which is helpful for extended text entries. Each of these elements adds flexibility and control over your data structure, allowing you to tailor it precisely to your needs. Whether you're creating individual items or generating them in bulk from a file, these settings help ensure consistency and accuracy in how your data is managed. To effectively manage your data, adding items to your data structure is a crucial step. When you select Add Item, you're opening a new window that allows you to customize various attributes for each item. This is where you can define elements such as the item's name, the type of data it will hold, and even set default values. Importantly, each data structure needs at least one item to function properly. The flexibility here is significant. There's no cap on the number of fields you can create. This means you can tailor your data structure to precisely fit your needs, whether you are managing a simple list or a complex data set. By thoughtfully specifying these items, you can organize and access your data more efficiently. When you're adding items to your data structure, it's essential to start by naming each item properly. Think of the name as the label that clearly defines what your data item represents. For instance, common labels might include name, address, or telephone number. This name is crucial because it's how the data item will be identified in both your data store and structure. Clear descriptive names help you and others understand the purpose of the item at a glance, making the data easier to manage and use effectively. Always aim for names that are straightforward and consistent with the kind of data you're working with. When defining items in your data structure, understanding data types is crucial. Data types determine how your information is stored and manipulated. They include text, number, Boolean, date, binary, array, or collection. Each type serves a distinct purpose. Text is for strings, number for mathematical operations, Boolean for true or false values, date for time-based data, and binary for raw data. Arrays and collections are complex types, allowing you to store multiple values or items, which means you can define more intricate structures within them. Choosing the correct data type is essential. Mismatched types can lead to validation errors. Imagine a scenario where a module expects a number but gets text instead. This discrepancy can halt processes and generate errors. By aligning your data types with their intended uses in your scenarios, you ensure seamless operation and data integrity. Always plan ahead. Knowing which data types you need will save time and prevent potential issues. When you're adding items to your data structure, it's crucial to understand the impact of setting default values. A default value is an optional setting you can define for your data type, ensuring data completeness. This means that even if no explicit value is provided, your records will still contain a value, maintaining consistency and preventing errors. Imagine a scenario where you need an email alert to trigger if an item's value drops below 10. Without a default value specified, your process might not execute correctly, potentially leading to errors or incomplete actions. By using default values intelligently, you can safeguard your data processes and ensure smooth operation. When adding items to your data structure, it's important to understand the role each option plays. First, you have the choice to make a field required or optional by selecting yes or no. Choosing yes means data must be entered for that field. This is similar to completing a contact form where some fields are marked as necessary, like an email or phone number. These required fields ensure that essential information is gathered for effective communication. By setting these requirements, you're maintaining data integrity and ensuring that processes move smoothly without missing critical data. To effectively add items to your data structure, you'll want to understand how different types handle formatting, especially with multi-line entries. Options like text, array, or collection allow your data to spread over several lines. Imagine you're crafting a message or a list where each line carries its own importance. These formats ensure everything is clear and organized. Think of a text field as a simple note where you can have one sentence followed by another neatly lined below it. An array, on the other hand, might store items such as a list of names or coordinates in a single organized sequence. Collections are like mini groups, bringing together multiple elements into one comprehensive package. By choosing the right format for your needs, whether it's single line or multi-line, you're ensuring the data displays just as intended, making complex information both accessible and easy to manage. To enhance your data organization, let's explore an efficient way to build your structure using JSON. Typically, you might manually add each element, but opting to insert a JSON string can simplify this process. By pasting it into the sample data field, you can quickly generate a structured setup that includes items, labels, and data types with just a couple of clicks. Once you click Generate, voila, you have a ready-made structure. However, remember that default values or requirements like multi-line options aren't preset in this step. You have the flexibility to configure these later to suit your specific needs. This approach is particularly useful if you're working with a large amount of data or complex structures. It's a time saver that also minimizes manual errors while giving you a robust framework to start with. How you choose to expand upon or customize your data is entirely up to you, making this method both powerful and adaptable. In this section, you'll embark on a practical journey to understand how to manage data using a real-world example. Meet Paola, who runs an online clothing shop. She's chosen to store her stock data in an organized manner by using Make's data store feature. This structure allows her to keep track of 4 items, each available in 3 variants like different colors or sizes. Paula's goal is to maintain a clear picture of her inventory and ensure she never runs out of stock unexpectedly. To achieve this, she's setting up a system that notifies her daily if the total quantity of any product falls below a specific level, 50 to be exact. Additionally, if any individual variant, such as a black t-shirt, drops below 5, she'll be alerted. This thoughtful use of data helps her stay proactive, whether it's ordering more stock or adjusting her inventory strategy. Before diving into these scenarios, it's crucial for Paola to have a well-defined data structure to support her online store's needs efficiently. Let's take the first steps in creating that structure. Welcome to the exciting process of creating a data structure for Paola's online clothing shop. Our focus here is on organizing her inventory data effectively. Think of data structures as a framework that helps in storing, managing, and using data efficiently. The first step is to define the essential attributes of each product. These attributes include the product ID, which serves as a unique identifier, and the name, which gives a clear label. The description provides detailed information that can help describe the item to potential customers. Next, categorize the item using the type attribute. This classification could be based on clothing type like shirts, pants, or accessories. For the unit attribute, consider whether items are sold individually or in sets. Variants are perhaps the most intricate part. They cover different options available for a product, such as size and color. Each variant includes a unique SKU, which acts like a fingerprint for tracking purposes. Additionally, it's essential to keep track of their quantity and price for accurate inventory and sales data. You have the option to create this structure manually or generate it using JSON. depending on your preference and time availability. Experiment with these methods, as understanding the creation process will enhance your skills in managing data structures efficiently. Now let's see how you can organize this for optimal use in Paula's store. Let's dive into creating your data structure step by step. To start, you'll add an item and give it the name ID. For its type, choose text. This sets the framework for identifying each unique product. You won't need to adjust other settings at this point, so let's keep it simple. Now replicate this process for 4 more items, naming each one name, description, type, and unit. Each of these elements helps to build a comprehensive profile of your product, setting the stage for more detailed attributes later. Taking the manual route enriches your understanding and control over the structure you're designing. Enjoy the process and take each step mindfully. Now let's build on the foundational data structure you started. First, add a new item and label it variant. When you reach the type selection, choose Array. This choice will adjust the menu and lead you to a new area called Array Item Specification. Here's where it gets interesting. From the type options in this new menu, select Collection. By doing so, you'll be setting up a framework for a list of sub-items, components that collectively describe your product. Imagine the array as a bookcase. Each collection within is akin to a book on that shelf. This method allows for organizing multiple details under a single category, making your data structure both flexible and powerful. Keep this analogy in mind as you proceed to develop a comprehensive and organized product description. Great work on choosing the manual approach. Let's dive into setting up your data structure by specifying the items within your collection. Imagine each product you handle needs details like identifying attributes or properties. For instance, a stock keeping unit known as a SKU acts like a unique identifier, a way to keep track of each individual product. You'll set this type as text because it's usually a combination of letters and numbers. Next, think about features that customers often consider, like color and size. These attributes help differentiate product variants and should also be set to text since they describe visual and physical properties. Now, onto the numerical aspects. Price and quantity are crucial for inventory and sales data. Numbers are their natural choice because they allow for calculations and quantitative data tracking. By organizing these elements properly, you're creating a robust foundation for product data management, ensuring each item is easily searchable and identifiable within your system. Remember, this collection method is like building a comprehensive catalog, where each attribute adds clarity and usefulness to your data setup. Great job choosing the manual route to create your data structure. This approach really lets you get hands-on with the process. As you proceed through this activity, remember to leave the default value of each item blank. This is because you'll be adding the actual data later in Unit 3. It's all about setting up the right framework right now. For any text fields, when you see the option for multi-line, make sure to keep it set to No. This will ensure your data entries are kept simple and consistent. By following these steps, you're laying a solid foundation for building your data store efficiently. Keep going, and you're doing great. You've reached the final step of creating your data structure. Well done on choosing the manual route. Here, you'll give your structure a unique name, make Advanced C01 data structure, to identify it easily during your projects. You've specified a basic yet crucial element, the ID. This is fundamental in nearly every data structure because it acts as a unique identifier for each data entry. Here, you've named this property ID and set its type to text. This flexibility allows you to use numbers, letters, or symbols accommodating various data needs. Now that your data structure is mapped out, all that's left is to hit the Save button. You've just laid a solid foundation for organizing and managing your data efficiently throughout this course. Great job, and get ready to leverage this structure in the coming lessons. Understanding data consistency and integrity is crucial for effective data management. Consistent data ensures that you can organize and plan your projects efficiently. A key part of this process involves choosing the right labels for your data types, like deciding between using name or first underscore name. Similarly, selecting the appropriate data type, such as text, is essential. If you change these decisions midway, it can lead to complications in data handling and recording. Imagine you're preparing to bake a cake. It's practical to keep all your ingredients like eggs, flour, and sugar together for easy access. This organization helps you find what you need quickly, just like how a well-structured data store functions. Here, the data structure is your ingredients, and the data store is the location where they're kept. Maintaining this consistency ensures that all your scenarios run smoothly, minimizing disruptions. When you define a data structure, it's essential to plan the data you need, such as names, ages, or locations. This early planning forms the foundation for effective data organization. Imagine your data is like a collection of baking ingredients. Just as you would keep flour, sugar, and eggs in specific places, you assign labels to your data for easy identification and access. Now, while it's possible to modify a data structure later, this could lead to challenges, especially with existing records. For instance, renaming a field in your data is like suddenly referring to baking soda as rising agent. If those using the data don't know about this change, they might struggle to find what they need, akin to a baker missing a crucial ingredient and ending up with a cake that won't rise. It's crucial to understand that such modifications can disrupt data mappings, leading to difficulties in data retrieval and usage. Essentially, any change to data structures, much like unexpected changes in a recipe, can have far reaching effects, making consistent, thoughtful planning vital for maintaining data integrity. In this scenario, we're exploring the importance of maintaining data consistency, particularly when modifying data structures. Imagine a data record that initially contains fields for name, age, and email. Now, if you rename the age field to years underscore old, you inadvertently create two separate identifiers for the same piece of information, age and years underscore old. This leads to inconsistency because new and existing data might not align seamlessly. When accessing this data, you're faced with two different versions, each holding separate records. This fragmentation can cause confusion and errors, particularly if systems or processes rely on a specific label. Moreover, when you view the data from within the data store, any field not correctly mapped may show up with an empty value, further complicating data retrieval and analysis. Ensuring consistency is crucial not just for data accuracy, but also for the efficiency and reliability of the systems relying on this data. This example highlights the ripple effects that can occur from simple changes, emphasizing the need for careful planning and execution when modifying data structures. Understanding data consistency and integrity is crucial when handling data structures. When we remove a field, like age in this example, it can create unexpected results in your data processing scenarios. Although any existing data will keep its record of age, new entries won't have this field. So if you try to map a data set that includes this missing field, you'll encounter inconsistencies. Imagine processing two records, one with the age field and one without. The record lacking this field will show an empty result, which could disrupt any modules relying on this data. It's vital to ensure your data structures are consistently applied, as this reduces errors and maintains the integrity of your data workflows. As we wrap up this section, let's take a moment to reflect on the essential role data structures play in organizing information. These structures are versatile tools, crucial for managing data across various contexts, whether you're working with webhooks, JSON, or data stores. Designing a data structure is a foundational step that underpins the functionality of your scenarios. It's important to remember that maintaining the integrity and consistency of your data structure is not just a technical detail, it can significantly affect how your scenarios perform. Any modifications to the data structure, like adding or removing fields, should be done thoughtfully to prevent errors or data loss. If you ever need to update a data store's structure, don't hesitate to consult resources like the help article mentioned. Understanding and managing data structures effectively is key to building robust, efficient scenarios. Congratulations on completing the first unit of this course. By now, you should have a solid grasp of what a data structure is, how to create one, and why maintaining consistency is essential. Data structures are the backbone of efficient data management, allowing you to organize, store, and manipulate data strategically. Creating them involves careful planning to ensure they meet the needs of various scenarios, whether for data stores, webhooks, or JSON files. The key to success lies in maintaining data integrity and consistency, as any changes can significantly impact how your scenarios function. As you move forward, keep these principles in mind to harness the full potential of your data structures in upcoming lessons. Great job, and continue to build on this foundation as you advance.